Hello again. Today we're going to be talking about how to determine what the variation is between two variables, whether it's direct or inverse, and whether there are powers involved. So let's get started. We're going to look at an example. The area of an isosceles right triangle is proportional to the square of its hypotenuse. So there's a graph here showing the relationship between those. So someone has obviously taken a bunch of isosceles right triangles and figured out what the hypotenuse is and figured out what the area is. And they plotted that graph right there. So I know that A is going to be proportional to C squared because that looks a lot like a parabola. I just don't know how much of a vertical stretch there is with that parabola, so that's what I need to figure out. That is actually also my constant of proportionality. That's what determines the vertical stretch of that parabola. So I know that the area is going to be some constant times the hypotenuse squared. I find a point that is on the graph, and so the C coordinate would be 2 and the A coordinate would be 1. So I plug those in and A equals K times C squared becomes 1 equals K times 2 squared. And if I solve that, I get that K would equal 1 over 4. So now I know what the equation of that graph is. I also know the relationship between the area of an isosceles right triangle and the length of its hypotenuse. So the area would be 1/4 times the hypotenuse squared. All right, here's another example where I have a table instead of a graph. And it looks like the variables are inversely proportional instead of directly proportional. And so what we're going to do is we're going to show that the relationship between those is inverse, so that y is inversely proportional to x squared. And we also need to find the constant of proportionality. So if y is inversely proportional to x squared, then I can write that x squared times y is some constant k. All right, I'm just going to look at the first column and plug in that value of x and that value of y, and I get that 0.25 squared times 160 is 10. If I try that with all of the other columns, I'm noticing that I get the same answer of 10. So that means that yes, y is inversely proportional to x squared and the constant of proportionality is 10. All right. So now what I'm going to do is I'm going to use that equation x squared y equals 10 to figure out the value of y if x was 5. So there's my equation, x squared y equals 10. Now that I know that k equals 10, I'm going to replace x with 5. So 5 squared times y is 10, which means that 25y is 10. And so if I divide both sides by 25, I will get that y equals 10 over 25, which simplifies to be 2/5. So this is just a little hint as to what you can expect whenever you are asked to determine the proportionality model between two variables. If you have any questions about that, please let me know and I will see you tomorrow.